Just half an hour lunch, where the kids were being stupid and they were racing, and some kids were in the trunk, and then they got in an accident. The kids flew out of the trunk and they died. So then they were like, we're canceled. All lunch is now closed. So at Glendora High School, it's only a closed campus, half an hour lunch. And so that's probably what we would do too. What's that? They are on a block schedule, but they still have only a half an hour lunch, closed campus. So, yeah, that's what everyone wants.
I'm good.
I don't know. There always is like I want to say there was a few years ago where there was a huge student movement to get rid of study period. They were like, we want to get rid of study period, and then we told them, okay, we could go back to half an hour lunch with closed campus.
No.
And then it like
it died out.
It was like it just died like
popularity gone.
Like the entire like whatever the form that they were filling out, it disappeared, and everyone was like, where'd it go? It's like it's not available anymore. So it just totally like everyone was like, no, that's not what we want. But it's like it's funny because people think, oh, everyone gets to have an hour lunch. It's like that's not how that works. All right, but let's go ahead and let's see if we can find some area. Did we do this one? Okay. I thought we did this one. Did we not? We did?
Okay, I gotta look at what I did again. I'm like, yeah, all I have to do is solve it. Like, I'll have to just plug it in and I'm good. Well, not plug it in. Just, like, we found the balance. Alright, let's just give it a shot then. Are you already done with it, or you just have to figure it out? I have it set up too.
What is A and B?
I have pi halves and pi.
Why?
Because pi halves would be, there's a drawing. Pi halves would be 1, and then pi would be 0. So I would go from here to here, and I just doubled it.
The pi to pi.
I think. Bless you.
Oh yeah.
Or pi halves to pi.
So if they're
Pi-
like overlapping and it's just a
Pi
common
halves
area,
to 2 pi. Like,
Oh, 2 pi?
so pi halves
Uh-huh.
is A, or alpha, and then
Okay.
A is pi.
This interval.
Yeah, I don't know, that's hard.
Oh, but we already know it's pi. Okay.
So we started this yesterday, but we just didn't finish it, I think, right?
Yeah. Sure. The
circle.
Uh-huh.
Half circle.
Here, wait. I'm like late here. I'll just try to solve it.
Was that in the military or? Oh.
What? Did I miss Mr. Kimblor?
Yeah.
I didn't hear.
Do you guys have belt rankings or?
Yeah.
What belt?
Oh,
It's like a purple belt.
Oh wow.
that's 3 halves.
It's in judo. Is it purple, brown, black?
Let me see what you got. I'm like right here. Let me see. Maybe I can just compare right now. Pi 3 halves. Yeah.
Yeah.
Yeah. Same setup. Okay, so I'll just keep going. So you got 5 pi over 4 plus 2. You didn't even want to simplify.
No.
Well, that would be.
Or cube.
Yeah, you get the same answer. It's fine. I think. It looks like it was backwards, but I think it's fine. So just add it. Is that right?
So just to let you guys know, if you did find the area of this, what's that called, semicircle of the circle, the way that you would do that is you would do the integral of 1/2, and it would be r is 1, so it's 1 squared d theta, because this radius is 1, and then we're going from 0 to pi over 2. Now, you could do that, but you should just know, and then we're going to use symmetry, so we're going to say 2 times that. But you should just know that this is pi over 4, and this is also pi over 4. So we have pi halves, right? So we talked about that yesterday, and then that would be this half circle right here. So that would be the area of this half circle. It's just pi, it's pi r squared, and so it's just going to be pi r squared is just pi, and we know that each of these is a quarter, so this is half, right? Let's look at that. So then this right here is just pi over 2. That's just pi over 2. And if you were to do this, you should still get pi over 2 as your solution, right? Hopefully everyone agrees we still get pi over 2 for our solution. Okay, so in any case, so that's the semicircle. The only other part we need is this red part here, which this red part here, we're gonna go ahead and find that, right, that area. And then once again, what I would do is I like to plug in 0 just to see where our function is starting. So if you plug in 0, theta equals 0 into your 1 plus cosine of theta, it's going to be 1 plus 1 is 2. So we are right here. So then that means that it looks like it's going to go right here at pi over 2. And so if we plug in pi over 2, cosine of pi over 2 is 0. 1 plus 0 is 1. So that does give us here. And then I would assume, or it looks like that this is theta equals pi. And if we plug in pi into that, cosine of pi is -1. 1 plus -1 is 0. So basically that tells us that we want to go from pi over 2 to pi, right? Does everyone get that? So then here it's going to be plus 2 times 1/2 the integral from pi over 2 to pi of 1 plus cosine of theta squared d theta. Okay, so that's really all you're solving for. And if you solve that, you should get your solution. So this right here, once again, this is just pi halves plus the integral from pi over 2 to pi of 1 plus 2 cosine of theta plus cosine squared theta, d theta. We are going to use what's that called? An identity for this. So we're going to use the power identity for that, the power reducer, right? So then this is going to be pi over 2 plus pi over 2 to pi of 1 plus 2 cosine of theta. And what is cosine squared? Okay, so it's 1/2 times 1 plus cosine of 2 theta, and then 2 theta. Okay, so you just have to memorize that power reducer. It's super useful, super handy. It's not that hard. Cosine is plus, sine is minus. That's really the only difference between them, right? So cosine's plus, sine is minus. And then here, we could go ahead and differentiate and evaluate. This is theta plus 2 sine theta plus 1/2 theta. And then this is going to become plus 1/4 sine 2 theta. If I did that right. So let's see here. If I distribute that half through, this is 1/2, this is 1/2 cosine of 2 theta. 1/2 cosine of 2 theta.
That's what we got.
So 1/4 sine of 2 theta.
Yeah.
That's right. Okay. So just have to be careful when I jump too many steps here. And then we just evaluate that. So pi over 2 plus. And then we're going to have here pi plus 2 sine of pi is 0, plus 1/2 pi over 2, and then plus 0 again, minus, then we have to plug in pi halves. So we're going to have pi halves plus sine of pi halves is 1, so that's going to be 2 plus pi over 4. And then that's going to be plus 0. Alright, so then it looks like we have pi halves plus, this is going to be 3 pi halves minus, and this right here is 3/4 pi minus 2.
Okay,
So
let me
that's
just, like,
2
quickly-
pi over 4 plus 6 pi over 4 minus 3 pi over 4 minus 2 minus 3 is 5 pi over 4 minus
Forgot to buy this.
Not even close.
All right. Okay. Little bit of good news. Pretty much most of these area formulas are going to follow. It's going to feel like this in terms of its integration, in terms of its anti-differentiation or its setup, and then the hard part, of course, is making sure you know your unit circle. Because if you don't know your unit circle, you're done, right? Like you're not getting the right answer. And if you don't know your unit circle and you're trying to figure it out, you're just wasting time. You're not going to be able to finish this in time, right? So time is an issue, especially on an FRQ. So if you're not comfortable with your unit circle, start getting your flashcards out, start practicing it because you just need to know it. You should be able to evaluate these. Actually, we didn't really have to evaluate much. These were easy ones, I hope, right? So they were all 0 and 1s, so that was nice. But
Happy
they're not
to get
always,
one.
not always, right? Okay. All right. Questions on this? All right. Let's try another one. And are we able to use geometry? So here I use geometry to figure out the area of the blue part of it. Are we able to use geometry on the AP Calculus exam and still get full credit?
What do you
I
mean?
feel like we're gonna say no.
Yes.
Okay, thank God.
You could just use geometry. Okay, so you don't have to use calculus. You could be like, that's a semicircle. So pi r squared, half of the area of a circle, and then that's fine. But you still have to understand that we're getting this half of the circle, right? And then you still have to graph this. Right? So you're still responsible for graphing it. So you are responsible for that. They expect you to know how to do that. Okay? They do expect you to know how to do that. All right. So in any case, that's a lot. We do get 5 pi over 4 minus 2. Try this one. Try this one. This one. Not too bad. Just set it up. On the AP exam, multiple choice, probably the most common question is set it up. What's the integral that would evaluate the area of this, right? So that's a very, very, very common question on the AP exam is what's the integral that will evaluate the area here. So you just have to set it up, and you set it up.
So this is
would this have been harder if I didn't give you the picture?
Yeah.
I think it becomes much harder if I don't give you the picture.
Yeah, I didn't realize how much that helped.
You just have to set it up. This should be very quick. This should be super quick. You don't have to do any algebra. You don't have to expand it or anything like that, just the setup. So a question that you should probably be asking is, would a question like this be on the multiple choice or the free response? Would it be on the calculated portion or the non-calculated portion?
Non-calculated.
It could be on either. It could be on either.
Oh.
Could this be a calculator question? It could be, which is nice because then you could graph it and you could be like, oh, okay, well, I just need this. But what happens if it's not calculator?
I gotta know what.
Then you have to know, right? And I'll just tell you, just plug in. I always plug in 0, plug in pi over 2, plug in 3 pi, plug in 3 pi over 2, plug in your axes, and then see if that helps you to kind of figure out what it's going to look like. So a lot of times that'll be it. And then you do have to kind of have an idea in your head. Oh, that's probably going to be some kind of cardioid, right? Because this is 1, and then this is 1 right there. So if those are the same, that's going to give you a cardioid. Okay, so just generally speaking. Okay, so this shouldn't be super hard. Should basically be 2 times 1/2 times the integral from 0 to pi over 2 of 1 minus sine of theta squared d theta. That's it. So if you wrote this, that would give you full credit on FRQ. And on a MCQ, it'll probably just reduce the 2.5. Could they also give it to you like this? Yes. They could give it to you like this, or they could give it to you like this. Will they use symmetry on the multiple choice? Yeah, absolutely. They're always going to use symmetry. Okay. The alternative to using symmetry is they have to do absolute value, and then you have to do a piecewise function. Which nobody wants to do that. Right? Nobody wants to do that. You just want to just use symmetry because that's just worse to do absolute value and then have to do a piecewise function. Okay. And then hopefully that's not hard. I will tell you I got this straight off of the AP exam.
Oh.
Okay, so this was straight off the AP exam.
Sweet.
It was in the non-calculator portion. Okay, and it was MCQ. And it did not give you the graph. Okay, so having the graph I think makes it easier. And then if you have the graph, it's really, I think it's just plugging into the formula. All right, we also have surface area. So let f be a function whose derivative is continuous from alpha to beta. The area of the surface area formed by revolving the graph of f equals f of theta from alpha to beta about the line theta equals 0, which is the horizontal or polar axis. So anytime you hear polar axis, your polar axis is your x-axis, is your generally what we consider to be the x-axis. That's your polar axis, okay? So anytime you see polar axis, that's what they're talking about, okay? So it's the horizontal or polar axis, which is theta equals 0, is this formula. 2 pi times the integral from alpha to beta of f of theta sine of theta times the square root of f of theta squared plus f prime of theta squared d theta. Now, you might say, what the heck? This is so crazy and hard, but it's actually not that hard. Why is it not that hard? Because this right here, this radical, you should recognize it. What is this radical?
I know what it is. It's called.
Arc length. That's right.
Right.
This is arc length. Right? This is arc length. Right? So this is arc length. And does everyone agree we could write it like this, or we could write it like this? Right? So this is, if you want to say f of theta, or if you want to use r, it's the same thing. Okay. Now, what is r sine of theta? Do you know what r sine of theta is? That's also a formula. That's y. So it's y times arc length. Y times arc length. 2 pi y times arc length. If you remember that, that's the formula. That's the formula. 2 pi times the integral of y times arc length. And that's it. If you remember that, that's surface area. Okay? So If you try to memorize it like this, I think that you could definitely get lost there. I just remember surface area is 2 pi y times arc length. Okay? 2 pi y times arc length. If you remember that, that will help you to remember surface area much more than if you just try to memorize this whole thing. That's about the polar axis. Could it also get rotated around the vertical axis? Yes. What do you think would happen if we're rotating around the vertical axis? That's it. It would be r cosine of arc length. So then it'd be x. Then it becomes x arc length. X times arc length, right? So it's always, this is always perpendicular to the line that we're rotating it about. And then arc length times arc length, okay? So this is the vertical axis. If we're rotating it around the vertical axis, theta equals pi over 2. Then it's just x times arc length. 2 pi, the integral of x times arc length. Okay? So we always multiply arc length times the perpendicular axis. Okay? Times the perpendicular axis. Or the perpendicular value, coordinate. Don't forget, tomorrow you guys have a quiz. You will have a quiz. And then no Desmos assignment, because you guys don't want a Desmos assignment. Unless you want a Desmos assignment. Okay. Does everyone agree that these are not terrible formulas if you have the correct way of thinking about them, right? If you don't have the correct way of thinking about them and you're just memorizing all of this, that's going to be a lot. You're gonna probably struggle with that. But if you just use what we already know, then it makes it a lot easier. Okay, so hopefully everyone's okay with that. So let's go ahead and look at an example. Find the surface area formed by revolving the circle r cosine of theta about the line pi over 2. So if I take this shape and I revolve it around the y-axis, what kind of three-dimensional shape will we have? It'll be a donut. It would be a donut. And what we're looking for is the surface area of that entire donut. That's what we're finding is the surface area of that donut. Right? Everyone get that? So what formula are we going to use? 2 pi times the integral r cosine theta times the square root of r squared plus r prime squared theta, right? So it's just our x times arc length, right? X times arc length. Okay, give it a try. I'm gonna have you guys give it a try.
Does this already have symmetry?
Oh, that's a good question. Should we use symmetry to do this? And if we use symmetry, what angle should we be using here? Okay, so in this one, we are going to use symmetry, and we're going to go 0 to pi over 2. Okay, so we are going to do 0 to pi over 2. So does everyone see what happens? And what we're doing is we're finding this the surface area of the top part of this, and we're rotating that. We're rotating that around. So this right here is getting rotated around. So So what we're doing here is, maybe I should. And so what's happening here is we have this shape that looks something like that. It's getting rotated, so it's getting rotated around, right? That's a terrible picture, but we're rotating and we're just doing the surface area of the top of the top part, and then we're going to do symmetry for the bottom part. Now, why are we going from 0 to 2 pi over 2? Well, what happens if you plug in 0 into this? You get 1. And then when will we get back to here? When will we get to this point? When it equals 0. So we're right here, this is at theta equals 0. And then this point is when theta equals pi over 2, right? So that's why we're going from 0 to pi over 2. That's giving us our entire section here. So what happens if we went from 0 to pi? Well, 0 to pi is going to give us the bottom half, but that will be negative, right? So then what happens when we add our positive and negative? It's going to give us 0, right? So we don't want to do that. So we want to make sure that we're using symmetry, because otherwise it'll give us 0, right? So we do want to use symmetry. So we're going to do the top half, and we're going to go from 0 to pi, because that's going to give us that entire top half of that circle. Okay? All right, so go from there. Go from there. There's really good news here for this problem. What's the arc length become?
Does it just become 1?
1.
Sweet.
When I saw the formula, I was like, oh my god, I used integration by parts. And then it became.
And then it clicked.
Right? This is actually a really nice problem. This is actually a super nice problem. They always give you a question that kind of works out nicely like this.
No.
No, they will not. Unless it's a non-calculator portion of the exam. If it's a non-calculator portion of the exam, they're generally going to give you something that works out really nicely like this. If it's a calculator portion of the exam, they're going to give you something that's not going to work out nicely, but that's okay. How come? Because you could just plug in your calculator and it'll just evaluate it for you. You just have to set it up, plug in your calculator, and then get your answer, right? I might not be so nice. What do you think is the likelihood I'm going to give you a polar question for your effort?
I got distracted.
You're supposed to do it now and reduce it.
I was thinking that. I started and then I was like, oh wait, I have to do power reducer, then I got distracted. What if I don't want to do a power reducer? Okay, fine, I'll do a power reducer.
Yeah. What do you? Well, this is what I. Oh, this you can. Yes.
What'd you say?
It's just my. Is this right?
Wait a minute, are you?
We're doing this, but that's something that's separate, right?
No, this is
Huh?
from here to here.
Oh.
0 to pi over 2. Does go to 0 over 2.
We do not.
Here's half the circle, and then we're just gonna double it.
I got till there, and then.
What?
So then if you-
You use the power reducer to reduce it to.
Yeah.
Oh, that's right. 1 week is really tough thing to miss.
Hmm?
Okay, so if you did this correctly, cosine squared plus negative sine squared, which is sine squared, cosine squared plus sine squared is 1. And the square root of 1 is just 1. So this is actually just cosine times cosine, which is cosine squared. At cosine squared, you should know you're going to use a power reducer right there, which is 1/2 1 plus cosine into theta. We could factor out that 1/2 out, and then it's going to become 2 pi. The antiderivative of 1 is theta, and the antiderivative of cosine of 2 theta is 1/2 sine of 2 theta. And we're just evaluating this from pi over 2 to 0. If you plug in pi over 2 into this is pi over 2. Sine of 2 times pi over 2 is pi, which is 0, and then sine of 0 is 0. So then this is just 2 pi times pi over 2, which is pi times pi, or pi squared. So if you got pi squared, that is the correct answer. Okay, so good news. If they give you a surface area problem on the AP exam, it generally will work out like this. This is pretty much the most common problem, right? Literally the most common problem. The only difference would be maybe instead of rotating cosine, they might do sine. And they're going to rotate that about the polar axis, right? So I think the number one thing that students get confused is when they see we're going to rotate around the polar axis, they're like, what does that mean? They're like, I don't know what that means. What's the polar axis? It's like, oh, that's your x-axis, right? So you're going to rotate that around the x-axis. And then basically it's the exact same thing except sine times sine. Right.
Remember that?
What's that?
Polar bears walk horizontally.
What's that?
Polar bears walk horizontally, so the polar axis is x.
It's horizontal.
Okay. Polar bears
Bears
walk
walk
horizontally. The
Along the
x-axis.
x-axis.
Along the x-axis. So that's your polar axis. Okay. So there you go. That could help you. All right. Let's see if you can do this one. Let C be the arc of the circle
God.
x squared plus y squared equals 9. From 3, 0 to 3 over 2, 3 rad 3 over 2 as shown in the figure below. Find the area of the surface formed by revolving C about the x-axis. Now the x-axis is the polar axis. What's the problem with this problem? It's in rectangular form. So guess what we'll have to do in order to find the surface area? Convert it to polar. Convert this to polar form, which is actually not as bad as you might think. It actually is
God.
really not as bad as you think. Convert this to polar form. Then so it's actually really not that bad. What's our polar function?
Squared.
So x equals r cosine.
Our polar function is
I don't know.
What?
r squared equals
X squared plus y.
Oh, yeah.
9. x squared plus y squared is r squared. So we can just say
Oh.
r squared is
3.
9.
Yeah.
Oh,
R
no.
is 3.
R is 3. R is 3. So if you think about that, that's not a really hard function. R equals 3, right? R equals 3. And then can you plug it into your formula?
Oh, yeah.
Plug that into your formula.
How does Sophia sit in this chair? Oh my god.
What?
Like,
Oh my god.
like it's horrible. I'm switching it.
What are the bounds?
Does anyone know what the boundaries are?
0 to pi.
We'll start from 0.
Let's start at 0, and we would use symmetry. We're gonna use symmetry, so we're only looking at the top half here.
Yeah, so pi.
Would it be 0 pi 6?
Oh, wait.
No way.
Pi thirds. Why pi thirds?
This is not going all the way.
It's not going, that's the angle, right? So right here, this is, our radius is 3, and then we're looking at this right there. And then if this is, our x value is 3 over 2, and our y value is 3 rad 3 over 2, right? What's the angle that allows us to get that? And then that would be, basically this is radical 3 over 2, this is 1/2, and that's when theta equals pi over 3. Right? That's that angle when theta equals pi over 3.
Is dr theta 0?
Yeah. Did you use symmetry?
You're supposed to use symmetry? I thought it was only. I thought you went down one.
Well, we're still doing only the top half here, but we still need the final half.
Oh, we're only doing. So we're going like that.
Yeah. Yeah. Because our angle here was. So we're only looking at this angle, but we still have the whole bottom half. You could do negative pi over 3. Oh, I think it would give you a negative value. I think it would give you 0, so we don't want to do that.
am I doing?
Rotate this around the polar axis. Which that's x. So you have to multiply it. And your function needs to be y. Which is sine of yes.